Hey everyone, I am Priyanshi Agrawal and welcome back to my channel. Today we will be solving Leetcode daily challenge, which is different ways to add parentheses. Okay, so let's see what is this question and how we can solve it. So in this question we have been given a string expression of numbers and operators, and we need to return all possible results from computing all different possible ways to group numbers and operators. And you may return the answer in any order, and the test cases are generated such that the output values fit in a 32-bit integer and the number of different results does not exceed 10 to the power 4. Okay, so in this question what we have given with this, we have given within expression. Let's take this example. So we have been given within expression, and we need to calculate the all possible results of this expression. Now you would say that what could be all possible results, like multiplication operator will be executed first, and then uh, and then these and then this negative operator, and then this subtraction operator, right? No, we have been given with that you need to calculate all possible results. Forget all these precedence operators. Nothing like the precedence of multiplication is more than the plus and then the negative operator. So forget all these precedents and you just need to calculate all the possible results of this expression. Okay, and from the constraints we can say that the operators can be only plus, minus and multiplication. We are not given with division operator, and all the integers will range in 0 to 99. So that's a good thing that we have been not given with this operator, because division operator might create the complexity in this question, because we need to handle the case of division by 0 as well. So that's a good thing. Okay, so we need to calculate the all the possible results. Okay, so like what could be its possible results? Let's say this expression will be executed first, and in this expression there could be two possible ways, like 3 minus 4 will be executed first, or 4 multiplied by 5 could be executed first. So there, in this way, there could be various possible ways for executing a single expression. Okay, so what we can do here is that how we can solve it. So let's say if we start iterating this expression, right? Okay, and whenever we encounter an operator, can we divide it into further subproblems? Okay, so let's see. So that whenever we encounter an operator, let's divide it in further subproblems. Okay, now again we start iterating this expression and again divide it into further subproblems. Okay, so let's say 3 and 4 multiplied by 5. Okay, again this is an expression, we will again divide it in further subproblem. Okay, now what we can see from here is that we have divided this in only a single way, but what could be other possible ways is there. On the left there could be 3 minus 4, and on the right there could be 5, right? And here it is further divided into 3 and 4. Okay, now let's compute their results for once. Okay, when 3 minus 4 gives us 1 minus 1, and then here from here 5, so it will become minus 1 multiplied by 5, so it will give us minus 5. Okay, now what this subproblem has given us the result, 4 multiplied by 5, that is 20, and 3 minus 20, that is minus 17. Okay, cool. So this subproblem could have given us all these possible results. Okay, now let's take the left subtree. So there is only a single expression, or I would say single integer, so this will return us the result only 2. Now from this side also we will return a vector, because now in this case there is single digit or number, but in some other case there might be some more integer, some more values. Okay, now we need to calculate all the combinations, or I would say all the possible values from here. So how we can calculate it? Let's say we have two vectors, 2 and minus 5 comma 17, and we have to calculate all the possible values of this expression. So we can apply the operator, this operator which we have in, at which we have started our tree. Okay, so my 2 multiplied by -5, that is -10. 2 multiplied by -17, that is -34. So you can see that there are two values, -34 and -10, and you can see this -10 is repetitive, so it might be the case that two different sub expressions are giving us the same value. Then we don't need to care that we need to insert that value in our answer vector only once. No, we can, there can be duplicacy in the answers as well. Okay, now you can see all the subtrees of this expression. Let's say we are dividing it at multiplication, then subtraction, and then again multiplication, and in this subtree this expression is calculated in this way, and in this subtree first 2 multiplied by 3 and then 4 multiplied by 5, and then subtraction operation is performed, and so on. So finally what we need to solve this question is that we first need to start iterating our expression, and whenever we encounter an operator we will divide it into further sub problems, right? We or further sub expression, and whenever returning we will return vectors from both the sides, and then apply that operation on these vector values, and we finally get our result. Okay, now let me quickly tell you its time complexity and space complexity as well, but I don't think that its time complexity will be much asked in interviews as it is very complicated to calculate it, but I will give you its overview, high level idea how we can calculate its complexity. So as you can see that we are dividing it into sub problems at each step. So for dividing it will be 2 to the power n, and at each step we are iterating the complete expression that could go up to maximum of n, right? So so n into 2 to the power n could be its complexity, but more complexity will come into picture, like whenever we while returning we will complexity of merging these two vectors or calculating the final value will also come into picture, but that becomes too much complicated to calculate, so I will leave it here only. So its complexity will be around n into 2 to the power n, and space complexity will be around 2 to the power n if we consider this output vector space, and if we don't consider its output vector space, then its complexity will all still remain 2 to the power n, because as this question involves recursion, and in the recursion the complexity of stack space will come into picture, like 3 minus 4 multiplied by 5. Its result will be stored at some point in our solution, but this is not the final result. That's why the complexity of recursive stack space will come into picture. So this will be its time and space complexity. Now let's try to code it, then we'll understand its approach. Okay, so what we have done is first we can create an operation vector operation function which will just find the value of our expression, and this is our operator, right? And whenever if operator is plus, then what we will return? We will return x plus y, and if operator is subtraction, then what we will return? We will return x minus y, and if operator is multiply, then what we will return x multiplied by y, as by the end of this function we can return 0. Okay, now in this function let's first declare our result vector, and then we will start iterating our expression, right? Expression dot length, and if expression of I is an operator, so in C++ we have an inwait function is digit expression of I, And if it is not a digit, it means it is an operator. Then what we need to do is we need to slice this into two subproblems, right? And store the result into two vectors, that let's say left, and again call that function recursively on the left side. So how we can call it? Expression dot sub str 0 comma I not included in this, right? And vector of int, right? Similarly again we will call this function recursively diff ways to compute expression dot sub str I plus 1 till the end. And whenever we got our values in the left and right vector, then we will iterate our left and right vectors and y right, and then we will calculate the value of the expression by that function, that is operation x comma y comma, and what will be our operator? Operator will be expression of I, right? And we will finally push this in our result in value. Okay, but here we have not applied any base case. So what will be here? What will be the base case? Base case will be when in an expression there is no operator, then it is in our base case, and we need to just return that string, or we need to return the integer, because we will convert the string into integer. Okay, so whenever our expression is something like, let's say 45, then obviously it doesn't contain any operator. Okay, if it doesn't contain any operator, then this loop will never be executed, and if this loop will never be executed, then result will be empty at that step. So we can say if result is empty, then the expression which we are encountering is just an expression which doesn't contain any operator, but it is an string, and then we need to push the integer. So we will push result dot push back string to integer expression, right? And then finally we will return result. Okay, now let's try run this. Yeah, it's working fine. Now let's try submitting it. Yeah, it's working fine. So I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.